Okay, algebra. Here is the last example I'm going to have you do on your notes from yesterday. So this is example 5. And what you should see here is that we have 3x, 5x, and then 4y and negative 9y. And none of those can eliminate, so what we're going to look for is we're going to look for one where we can easily change it to one of the other ones. And you can't. 3 doesn't go into 5, 4 doesn't go into 9. So now what we're going to look for is, do we have opposites somewhere? And on the y's, we have a positive 4y and a negative 9y. So that's going to be easier to change so that we don't have to mess with changing any negatives. So they already are the right signs. We just need to change it to where it's a number that's the same. So this is what you're going to think about. You're going to think about that least common multiple. What's the first thing that 4 and 9 both go into? And the only thing the first thing they both go into here would be 36. So that means that we need to change it to where they're 36y and negative 36y. So I need to multiply that top equation by 9, and then I'm going to multiply the bottom equation by 4. And what that's going to do is that's going to change your 4y to 36y and your negative 9y to negative 36y. But you know you have to do the whole equation. So we're going to end up with two new equations. So I'm going to write this down here. So 9 times 3x is 27x. 9 times 4y is 36y. And then 9 times 13 is 117. And then now I'm going to do the bottom equation by 4. So 4 times 5x is 20x. 4 times negative 9y is negative 36y. And then 4 times 6 is 24. Okay, so now we've done that. We're going to add vertically. We know we cancel out our y's, and we can add our x's, and we get 47x equals, and that's 11, 2, 3, 4, 141. My guess is 47 times 3 is 141, but we'll double check. 3 times 4 is 12, plus 2 is 141. There we go. So when we divide by 47, even though this didn't look like very friendly numbers, it works out evenly, we get x equals 3. All right, I'm going to erase this right here. I'm going to write my x equals 3 up kind of out of the way. So I have 3, comma, and then I need to find my y. Now what you can do is you can take that x equals 3 and you can plug it into any of these 4 equations, because all 4 of those equations, x is 3 and y is whatever it is when x is 3. But I'm going to use one of the top 2 because they're friendlier numbers. They're not gigantic numbers. So I'll use that very first one. So I'm going to say, I'm going to switch to a new color, 3 times 3 plus 4y equals 13. So I get 9 plus 4y equals 13. When I subtract 9 from both sides, I get 4y equals 4, which I then divide by 4, and it gives me y equals 1. So y equals 1 here, and our ordered pair is 3, 1. Okay, so again, remember, if you have opposites, then you don't have to multiply by a negative at all. You already have a positive sign and a negative sign, so that makes it easy. That was the last example that from the textbook, but I'm going to do a couple more examples. This next one is your option to write down, but the one after that I want you to write down because you will have one like it. So if you want, with this example right here, you can pause the video, write it down, and try to do it on your own and see if you get the right answer, and then come back and watch me do it and see if you ended up with the same ordered pair. So that might be a thing to do. Alright, so what I'm going to do is I'm going to look at my x's, and they're not positive or not opposites, and the y's aren't opposite, or the y's are opposites, but they're not the same number. So since the y has a plus y and the 2y is a negative 2y, I'm just going to go ahead and try to eliminate my y's. So all I need to do is I need to make this one 2y instead of just being y. So I'm going to multiply the top equation by 2, and that's going to give me 2 times 3x is 6x, 2 times positive y is positive 2y, and then 2 times negative 11 is negative 22. And so now I will add down. 6x plus 6x is 12x. My y's eliminate. Negative 2 plus negative 22 is negative 24. Now I'm just going to divide by 12, and I get x equals negative 2. So I'm going to put that in an ordered pair up here. And that was x. So now I'm going to solve for y. And I can put it in either equation, or any of the three equations, this one, or this one. But I'm going to go ahead and do this one because y is already actually by itself a little bit, so that makes it a little faster. So it's going to go negative 3 times negative 2 plus y equals, whoops, ran out of room, negative 11. So negative 3 times negative 2 is positive 6, so I have positive 6 plus y equals negative 11. Now I'm going to subtract 6, and I end up with y equals, I'm going to add these together, negative 17, which is weird, but that's correct. So it's negative 17. So if you did that on your own and then came back to check, then you probably thought that was an odd answer, but that is going to be it. Okay, so this next one I do want you to write down because your number 20 is just like this. This is actually number 19 in your textbook. But when you do 20 on the homework, it's going to look like this. The problem here is if you notice, this equation right here is not written the same as the bottom one. I mean, it does look like the x is on top of x, y is on top of y, but the equal sign is in the wrong place. So basically what we want is we want it really kind of in standard form. So we're going to move the y term over to the left side. So what I need to do is I need to just add 11y to both sides. So my top equation is now 8x plus 11y equals negative 16. And that's going to make it better to eliminate because x is on top of x, y is on top of y, equals is on top of equals, and our constants are lined up as well. So just make sure that they're in the same place. So on number 20, you're going to have to do the same thing on that bottom equation by moving the negative 4y over up to the other side. Alright, so now we'll look and see what we have and what we can eliminate. We don't have opposites, we have all positive numbers. So since 2 and 8 are friendly, 2 goes into 8, I'm going to change it where we will eliminate the x's this time. So all I need to do is multiply that top equation by 4, by negative 4, so I can make that 2x a negative 8. So I'm going to do that underneath. So negative 4 times 2x would be negative 8x. Negative 4 times 3y would be negative 12y. And then negative 4 times negative 4 is positive 16. Alright, so that eliminates my x's. And 11y minus 12y would give us negative 1y. And negative 16 plus 16 is just 0. So that tells us that y is 0. So I'm going to put that in my ordered pair, 0 there. Okay. Then I'm going to plug that in to get x. So remember, I can use any of my three equations. I'll go ahead and use this top equation because x is almost by itself over there. So I'm going to switch color. There we go. So 8x equals negative 11 times 0 minus 16. So that's just 0, so I end up with 8x equals negative 16. Dividing by 8, I get x equals negative 2. So that is my ordered pair, and there is my solution. So that is it, and I hope that is helpful, and you guys do okay today. You're doing numbers. Oh, there's that. I wondered what happened to that. Oh no, I want to do this one too in just a minute. Okay, but I'm going to go ahead and tell you your assignment. If you want to stop and go ahead and get to work, if you feel pretty good about it, you can, or you can do this assignment, or you can watch me do this problem too. So you're doing numbers 2 through 24 evens on page 269. Okay, and just know number 18 has one fraction. It's a fairly normal fraction, so don't get freaked out if you get a fraction answer. That is correct on one of them. Alright, so I'm going to go back to this one. This is actually example, or number 23. I did this one because it was one like that last example 5 where you have to multiply both equations by something. So if you want to pause and try it on your own and then see how you do, come back and watch it, that's a good idea, or you can just watch me do it. Okay, so if you notice, our x terms are not the same, y terms are not the same, we don't have opposites on either one of them, so we're going to have to change both equations. So what I'm going to do is I'm going to look, I think I'm going to go with the x's just because they're small, a little bit smaller, and I need to change them to something that's the same. So I'm going to look for that least common multiple. What's the first thing 4 and 6 go into? And the first thing that they go into would be 12. So instead of just going all the way up to 24, I can multiply to get them to be 12 and negative 12. So I think I'll make the 4x into the negative 12x, which means I'm going to multiply the top equation by negative 3. So that's going to make 4x a negative 12x. That means I need the bottom one, the 6x, to stay a positive 12x. So I only need to multiply the bottom equation by positive 2. Okay, so I'm multiplying both equations, but I need to multiply one by a negative and one by a positive, so I end up with one of each. And you could have multiplied to eliminate the y's, and 6 and 9 both go into 18, so you could have multiplied by, well, actually, you'll see what happens here. Okay, so 4x times negative 3 is negative 12x. Negative 3 times negative 6y is positive 18y. And then negative 3 times 8 is negative 24. So there's the first one. Doing the bottom one, 2 times 6x is 12x. 2 times negative 9 is negative 18y. And then 2 times 12 is 24. Okay, so this one did work out to where it ended up being where you would eliminate everything. If you notice, they're all opposites. So when I do this, that's 0, that's 0, and that is 0. I end up with 0 equals 0. So it's an infinitely many solutions. I wasn't doing this because of the solution that it would be. I was doing this because you were going to have to multiply both equations like that. So you just have to really think about it when you do those kinds of problems where you might have to multiply both equations and one by negative and positive. That takes a little more time. So that's it. Good luck, and I will see you guys on Monday.